Pluto, a perplexing and enigmatic body, was once considered a solitary planet, a member of our planetary system. However, ongoing discussions by leading astrophysicists like Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the spotlight with a fascinating revelation. They proposed that Pluto might be on a potential collision course with Neptune. This raises intriguing questions. How could such an event occur, and what would the consequences be? Is this a captivating anomaly or a mere coincidence, or is there something more to this impending cosmic event? Join us as we explore the possible implications of a Pluto-Neptune collision. Once deemed a planet, Pluto, now relegated to a smaller status, remains a subject of interest and study in the astronomical community. According to ongoing studies by prominent experts, Pluto's orbit is dangerously close to Neptune's, which has prompted astrophysicists like Tyson and Kaku to warn of a potentially catastrophic encounter between the two planets that could pose a significant threat to Earth. But how is such a collision even feasible? Pluto's orbit around the Sun is distinctive compared to the other planets in our solar system. It takes an extended 248 years to complete a single orbit, meaning that since its discovery in 1930, Pluto hasn't even finished one full revolution yet. But the intrigue doesn't end there. Pluto's orbit is defined by its highly elliptical shape, which is in stark contrast to the nearly circular orbits of the major planets. What makes Pluto's orbit even more unpredictable is its inclination of 17 degrees to the ecliptic plane. This makes Pluto's trajectory notably more erratic compared to other planets, adding complexity to its orbital behavior. Perhaps one of the most fascinating aspects of Pluto's orbit is its interaction with Neptune's. For about 20 years in each orbit, Pluto actually comes closer to the Sun than Neptune, defying what we'd expect based on their positions in the solar system. This prompts a crucial question. Why hasn't Pluto collided with Neptune? The answer lies in the gravitational influence of other planets. Following Pluto's discovery, space scientists began studying its unusual orbital path. Unlike the orbits of other planets that lie nearly on the same plane, Pluto's orbit stands out due to its steep inclination and irregular shape. The mystery of Pluto's orbit is often explained by the three-body problem in celestial mechanics, which involves understanding how three objects, such as Pluto, Neptune, and the Sun, interact through their gravitational forces. It's akin to predicting where these bodies will move based on their initial positions and how they pull on each other. This three-body problem helps explain why Pluto and Neptune, despite their seemingly intersecting orbits, have not collided. A critical concept at play here is libration. In the case of Pluto and Neptune, libration means that when Pluto crosses Neptune's orbit, it is positioned approximately 90 degrees away from Neptune, which keeps their paths from interfering with each other. Libration also refers to the vertical movement of a celestial body within its orbit. For Pluto, this means that when it comes closest to Neptune or any large planet, it moves above the orbital plane, further preventing any potential impacts. Another key factor in preventing a collision is the VZK wobbling, named after the researchers V, L, and K. This effect describes how Pluto, Neptune, and the Sun's gravitational forces interact and influence their movements. Despite the apparent randomness of Pluto's path, the VZK wobbling stabilizes its orbit over long periods, preventing Pluto from drifting off course or colliding with Neptune. This three-body dynamic ensures that Pluto's orbit remains stable and avoids chaos, even in the face of such complex forces. Simulations from the late 1980s showed that, despite Pluto's seemingly chaotic orbit, its path remains stable, with minimal deviation from its original course. These deviations, though small, could lead to large variations over time. However, Pluto's orbit has consistently followed a stable trajectory, supported by the influence of planets like Jupiter, Saturn, and Neptune. These planets play a crucial role in maintaining the stability of Pluto's orbit, with Jupiter's gravity being strong enough to keep Pluto on a steady course for billions of years. Jupiter's gravitational pull, along with the contributions of Saturn, helps prevent Pluto from veering off course or being ejected from the solar system. This collaboration between planets demonstrates the delicate balance that exists in our solar system. Without these stabilizing forces, the planetary system could be far more chaotic, with bodies like Pluto possibly colliding with others or being flung out of their orbits. The interaction between Jupiter, Saturn, and Neptune seems to be a cooperative effort to ensure Pluto remains on its path, potentially for billions of years. This dynamic illustrates the importance of these gravitational interactions in maintaining order within the solar system. Without them, the stability of smaller bodies like Pluto could be compromised. Understanding these forces is essential for grasping the larger structure of the solar system, where even irregular orbits can remain stable over vast timescales. Pluto's case highlights how even the most seemingly unstable celestial bodies can maintain equilibrium through complex gravitational interactions and orbital mechanics. Mathematical simulations and digital models have been crucial in studying the behavior of Pluto and other celestial objects. These simulations recreate how Pluto, along with Neptune and other planets, moves under the influence of gravity. By fine-tuning these models, astronomers can explore how small changes in Pluto's position or speed could drastically alter its orbit over time. Despite its seemingly erratic orbit, Pluto's trajectory remains stable for billions of years, underscoring the complex nature of celestial mechanics. While Pluto's orbit may seem tumultuous, especially compared to the smoother orbits of other planets, it follows a distinct order that has been shaped by the interactions of gravity and orbital forces. This brings us to a crucial realization. The inherent unpredictability of orbits like Pluto's presents challenges in making long-term predictions. Although mathematical models have helped us predict the behavior of celestial bodies, they also highlight the limitations of our understanding. Small deviations in initial conditions can lead to vastly different outcomes, making accurate predictions of Pluto's future movements extremely difficult. The unpredictable nature of orbits like Pluto's serves as a reminder of the dynamic and ever-changing universe we live in. While we've made great progress in understanding space, Pluto's case illustrates how much there is still to learn about the forces that govern planetary systems. The complexity of Pluto's orbit and its interactions with Neptune and other planets exemplify the intricate forces at play in our solar system. As astrophysicists like Neil deGrasse Tyson continue to explore the vastness of space, they help deepen our understanding of the delicate balance that governs celestial bodies. While the possibility of a Pluto-Neptune collision is not an immediate concern, it serves as a reminder of the constantly evolving and unpredictable nature of the universe. Despite the scientific understanding of Pluto's orbit, it's crucial to consider the broader implications of these gravitational forces on our understanding of the solar system and the universe as a whole. Pluto's journey is not just a tale of intrigue. It highlights the mysteries and complexities that remain to be explored in the vast expanse of space. The concept of orbital resonance, particularly between Pluto and Neptune, is an essential piece of the puzzle, illustrating how even chaotic systems can stabilize through gravitational forces. This resonance, where the ratio of Pluto's and Neptune's orbits is 2:3, is a critical element in celestial mechanics. For every 2 orbits Pluto completes around the Sun, Neptune completes 3. This resonance helps ensure that despite their intersecting orbits, the 2 planets never collide. Gravitational interactions between them maintain their stability and prevent catastrophic impacts, underscoring the self-regulating nature of space systems. This resonance, along with the stabilizing influence of planets like Jupiter, Saturn, and Uranus, is crucial for maintaining the consistency and stability of the planetary system. Without these forces, the solar system could be a far more chaotic place. In conclusion, the study of Pluto's orbit provides valuable insights into the complex dynamics of celestial bodies in our solar system. While Pluto's orbit may seem chaotic at times, it remains stable due to the intricate interplay of gravitational forces. The possibility of a Pluto-Neptune collision, while fascinating, serves as a reminder of the ever-evolving nature of the universe and the need for continued observation and study of the forces that shape the cosmos.